Hello everyone, welcome to the Nonlinear Resistance Practical of Semester 2. First, let's identify the objectives of our lab session. To study and compare resistance variation of a filament lamp, a standard resistor and a standard resistor and filament lamp series combination. Before moving to the practical, let's identify the theoretical background of this practical. Most of the resistors show some variations in resistance when current is flowing through them because of the changes in the temperature. Standard resistor shows very small variations, and for most applications they are considered as constant. A resistor such as filament of an ordinary light bulb shows large variations in resistance. This happens due to two reasons. The first one is the filament is subjected to heavy heating due to current, and the second one is the filament is made of material which has high temperature coefficient of resistance. The resistance variation with current of an ordinary light bulb and a standard resistor which has the same resistance as zero current are shown in this figure. A series combination of a standard resistor and a lamp has a resistance variation more linear than the filament lamp alone. Let's move to the procedure. Now let's have a look at the equipment used in our practical. Part A. Measurement of filament lamp. Using an ohm meter, measure the cold resistance of the lamp and note down the reading. Connect the This is the variac. The AC output from the variac is converted to DC by an AC to DC converter. Positive terminal of the DC source is connected to the rheostat. Rheostat is also connected to the positive terminal of the ammeter. Negative of the ammeter is connected to the lamp, and the lamp is connected to the negative terminal of the DC source. The voltmeter is connected parallelly to the lamp. First, turn on the supply. This is the initial value of the current when the DC supply is 110 volts. Then gradually increase the resistance value until current becomes 20 milliamperes. Measure the voltage across the lamp. Repeat the practical for different currents in steps of 10 milliamperes. Here are some sample observations that we received after conducting the practical. Part B. Measurement of standard resistor. Set the value of the standard resistor for resistance equal to the cold resistance in Part A using an ohm meter and note down the reading. Connect the circuit as shown in the lab sheet and measure the voltage across the resistor for different currents in steps of 10 milliamperes up to about 150 milliamperes. Turn on the supply. This is the initial value of the current when the DC supply is 110 volts. Then gradually increase the resistance value until current becomes 20 milliamperes. Measure the voltage across the standard resistor and repeat the practical for different currents in steps of 10 milliamperes up to 150 milliamperes. Here are some sample observations that we received after conducting the practical. Part C. Measurement of standard resistor and a filament lamp series combination. Connect the circuit as shown in the lab sheet with the standard resistance as in Part B, and measure the voltage across the series combination and across the lamp for different currents in steps of 10 milliamperes up to about 150 milliamperes. Turn on the supply. This is the initial value of the current when the DC supply is 110 volts. Then gradually increase the resistance value until current becomes 20 milliamperes. Measure the voltage across the series combination and across the lamp. And repeat the practical for different currents in steps of 10 milliamperes up to 150 milliamperes. Here are some sample observations that we received after conducting the practical. Do the calculations using the readings obtained when the practical is carried out. For discussion, answer the following questions.